Saxon's Trigonometry Lesson 7 is about inductive and deductive reasoning, logic, the contrapositive, and the terms converse and inverse. So let's talk about these terms, inductive and deductive reasoning. Inductive reasoning, if you're following the bolded words, says that you were basically inducing, looking for, using your logic to create a rule. Once you have established a rule, deductive reasoning is the process that uses that rule. So in their wording here, inductive reasoning is the process of gathering data, making observations, and then guessing. Deductive reasoning is the process of using a rule once it has been formulated. If the rule is false and the rule is used properly, the conclusion reached can be false. So you're going to hear in part B, I'm going to make a statement about the truth and the not truth of a statement. So in part B, logic, we are, they have a lot of bolded words here. The study of logic is called syllogism. And it's going to begin with a premise, a basic concept. And your job in this deductive reasoning is to take your premise and assume for that particular problem that your premise is truthful. Now, I might be saying the sky is purple. That's not necessarily truthful. But for that problem, I am assuming that the sky being purple is truth for that problem. That's my premise. And the premise can also be called a universal affirmative. We tend to not use that in the book, but be aware that that is a term. Okay. We begin by looking at the syllogism in which the premises are called, categorical propositions, because they place things in categories, and that's where I'm saying you have to accept it as true. All right, the major premise is the first statement. The minor premise is the second statement that will be compared to the first statement, which is your truth for this particular problem. And then lastly, there will be a conclusion. So, if you're following what they're doing in the book, it says all men are mortal. That's your major premise. We're not dealing with whether that's true or not in the real world. We're just taking that as truth at this point. Aristotle is a man is the minor premise. So if all men are mortal and Aristotle is a man, is the conclusion correct to say Aristotle is mortal? Yes, because it fit the pattern. Men are mortal, Aristotle's man, he is mortal. Okay, how about the next one? The sum of the exterior angles of a convex polygon are 360 degrees. That's going to be my truth for this particular problem. The sum of all the outside angles is 360. I have a triangle ABC and it is a convex polygon. Can I conclude that the sum of the exterior angles is 360? Yes. Okay, now, next one. All frogs are green. That's my major premise. Henry's a frog. Can I conclude that Henry is green? Yes, that is a valid conclusion. Okay, last one on page 55. If it rains, I will go to town. It did not rain is my minor premise. Therefore, I did not go to town. All right, here's my problem. My major premise was if it rained, I go to town. I do not know anything based on that first statement that deals with not. It did not rain. Now, in a moment, I'm going to talk about a converse and an inverse that might help me unlock and get to some other conclusions. However, in this one, since I know nothing about not raining, it's an invalid conclusion. Okay, on page 56, we now get to their actual example. Is the following argument valid? Why or why not? All normal frogs have 4 legs. Dogs, try that again. All normal dogs have 4 legs. The dog has 4 legs. Therefore, the dog is normal. Okay. It said all normal dogs have 4 legs. That's the only thing I can use. Their minor premise said the dog has 4 legs. So is it acceptable, is it following the correct flow to talk about the 4 legs and draw a conclusion? No, the only thing I can do is draw a conclusion from all normal dogs, not if they have 4. So it's invalid because it did not follow. Okay, so I'm going to start teaching you by going back over that one, this pattern of how things flow. So since my major premise said all normal dogs have 4 legs, P is going to stand for normal dog. Q is the conclusion for legs. Okay. So my original statement said, if I have a P, I'm going to a Q. My minor one said the dog has 4 legs, which was Q, and wanted to conclude P, and that's working backwards, which is why it was invalid. The only thing I can do is the P yields Q. So if the problem had said all normal dogs have 4 legs, Henry's a normal dog, making this a P, and the conclusion is Henry has 4 legs, P goes to Q, fits this, and that is a valid statement. All right, so let's kind of do the same thing with the P and the Q for example 2. Is the following argument valid? Why or why not? All boys are good. So P is boys. Conclusion, good. So we're obviously having to follow P yields Q. All boys are good. That child is good. That's Q again. Therefore, the child is a boy. Again, that's backwards, invalid. Example 3. Is the following argument valid? Why? All chickens have 3 legs. Chickens. Conclusion, 3 legs. P should yield Q. Minor premise, Henry Penny is a chicken. That's P. Conclusion should say Henry Penny has 3 legs. P went to Q. Yep, that is a valid argument. Now, is it truthful to say that chickens have 3 legs? No. So this is not truthful as in real world facts, but for the flow, this is correct. All right, I said we would get to the terms converse, inverse, and then this C, which is contrapositive. Okay. So I'm looking for, I thought their rule was actually written here. Okay, for a contrapositive, you are basically reversing. So if the original is P yields Q, the contrapositive will be reverse it and inverse it. So negative Q yields negative P. Did I give you an example? Yes. Okay, let's jump to example 4 and see if this pattern holds. Is the following argument valid? All non-athletes are vegetarians. Okay, so P is non-athlete. Conclusion is vegetarian. So we know our first statement is P yields to Q. The next thing it says is Jim is a non-vegetarian. So they're giving me not Q. Okay, now so from before, if it didn't fit the actual, I couldn't draw the conclusion and it was invalid. However, if the contrapositive, flipping and negating it works, then it's going to be okay. So we're going to take our first statement and we are going to do its contrapositive. So we're changing it to negative Q yields negative P. Minor premise was negative Q. So according to this then, that would be negative P as a valid conclusion. Well, the opposite of P would be they are an athlete. So what did they conclude here? Therefore, Jim is an athlete. Yes, that works and is a valid argument based on changing the major to its contrapositive. And that was example 4. Part D finally gives you the converse and inverse. So contrapositive is a combination of flip it and negate it. These others are the individual pieces of that. So converse, when you start with P yields Q, the converse is when you just flip that to Q yields P. And then the inverse is where you negate it. So it goes to negative P yields negative Q. Now theirs are a little more squiggly like when they do their negate rather than a minus. That is the technical mathematical knot for these kind of statements. I tend to kind of default to just the minus sign because that's the way it feels like I'm doing it, but we should be very, very precise. Now, the final thing that they give you here in this terminology is this statement P, and it's like a doubled arrow, and it's an if-then statement. So if P is true, then Q is true. And they don't do any examples with this, but they also say that it works both directions. That's why the arrow goes both ways. If Q is true, then P is true. And that's an if-then statement. And it'll actually have the wording in a problem if they're wanting you to use the if-then. But for now, this is where their focus is. Do you need to write out these things in order to get your answer for the questions in the homework? No, you don't. You can, if it is helpful, to see these things written out, but you can just use your logic on is it flowing or is it not flowing to get whether it's valid or invalid, because I'm not looking for this kind of stuff when I'm checking for answers.